This is the solution to WEX 043. Okay. For this one, we've got a nice formula that tells you what to do with a minus b all squared. So that would be the first thing, squared minus 2 times the first thing times the second thing plus the second thing squared, like that. Collecting and simplifying and what have you. This would be 16 w squared, and then minus 2 times 4 is 8 times 6 is 48. So 48 w, and then plus 36. For this one, we will need to do a distribution there. So this will be, watch, so I'll distribute it like this. So distribute, distribute, distribute. So then that would be 3x squared multiply 4x plus 5 plus 2x multiply 4x plus 5 plus 6 multiply 4x plus 5, and now we'll distribute the other way. So this one to that one, that would be 12x cubed. This one to that one, that would be 15x squared. Two x times 4x, that would be 8x squared. 2x times 5, that would be 10. X's, 6 times 4x would be 24. X's and 6 times 5 would be 30. And then collecting, so those are the only cubes right there. So 12x cubed, concerning the squares, just those two terms. So 15 and 8 would be 23. X squared, 10 and 24, so that'd be 34. X's, and then plus 30. Concerning this, let's see. Well, you could write that this is cube root, and then that 256 can be factored as 4 times 4 times 4 times 4, and then could write the w as, say, w cubed times w squared, and then z cubed is already good to go, and then y to 4 I'll write as y cubed times y. So now every triplet, like the triplet of the 4's there, blah blah blah, and the w cubed and the z cubed and the y cubed, all of those can come out. So there's a triplet, there's a triplet, a triplet, a triplet. So all of those come out, and when they come out as a singlet. So this would be 4 w z y, and then multiplied by a cube root of now what has to stay inside that 4. W squared stays inside, all the z's made it out, and the y remains. So notice that what remains in there, there's no more triplets. So all the triplets came out as singlets. All right. So then now, to do this, instead of triplets, now we want quadruplets. So let's see, how does 96 factor? So 96 over 4. And then, how about 96 over h? What is that? 12? Yeah, there we go. So, oh wait, I don't want it over, not 8, because 8 would be a triplet of 2's. 90 over 16, there we go. 96 over 16. So this would be 4th root of, so I'll write 16 multiplied by 6. So that's the way we want to do that, because that's 2 to 4. So then multiplied by b cubed multiplied by, and now I'm going to write this as a to 4 times a to 4 times a, and then, oh look, another b cubed. So that's tricky, right? So then combining the b cubed, that's actually a b to 6. B to 6, because those are coming together. Okay, so this 16 and this a to 4 can come out. That quadruplet will come out as absolute value a, so this will be 2 absolute a, and then multiply by 4th root of, well, what remains? That 6 remains, and then I'll write that b to 6 as b to 4 multiplied by b squared, like that. Now this b to 4 can come out as a singlet, but in absolute value, so this would be 2 multiplied by a to 4 multiplied by, 2 multiplied by absolute a multiplied by absolute b. And so what remains in here is 6b squared. And then this would be fine for an answer. Whoops, something got left off. So that that a got left. So this is multiply a right there, and then multiply a. Now that would be fine for an answer. But a topic that we talked about after this was something called natural domain, and concerning this expression, 96, blah blah, all of that. In order for this to be defined, a is not permitted that a should be negative, because if a were negative, a to 5 would be negative, and then the 4th root would not be defined. So, in fact, it's permitted that you can drop the absolute value on the a because of natural domain considerations, but not on the b, because without regard to whatever the sign of b is, what's left in there is b squared, which is never going to be negative.